Welcome back. Let's talk about some advanced REST design topics now. This module, we're going to start by talking about associations in APIs, how to design for paging, how to handle errors, how to plan for caching, what functional APIs are, as well as asynchronous APIs. Let's get started. When I talk about designing associations, what I'm really getting at is the idea of using a URI path to get at objects that are related to other objects. Some people may call these relational APIs, but I think associations makes more sense, at least to me. This is really used for sub-objects. You can use URI navigation. And in this case, we can see that these APIs are pointing at a specific customer in this first case, and then looking at the sub-object, the invoices that are assigned to these customers. The same for something like games and Halo, where you're pointing at an individual game and then looking for its ratings, invoice, date of the invoice, and then payments. The idea here is to follow that path down so that the URI is describing that in a very specific way. These associated APIs are going to return the same shapes. So customers 123 invoices should return the same shapes as API invoices. You may often have two different APIs that return the same types, but you're getting at them in different ways. A single endpoint can have multiple associations, so invoices for customers, payments for customers, shipments for customers. And if you need to get something specific, instead of making that an association, more normally you should use query strings to do that. So in this example, we're saying get the customers that are in the state of Georgia in the United States. And then we might add another part of that search to say whose sales ID is 144. That might be a salesperson's ID number or something like that. You could even look at these searches as using query strings to say, go get me the customers that have open orders. I like the idea here that the URI has this thing called a query string, and that it's the most natural way to describe your APIs by using the query string to do queries. Let's take a look at some examples. So let's see this in action. We're back to Visual Studio using those REST files again. And let's just look at the projects. And I'm going to switch this back to JSON, a little easier for me to make sense of it. And here we're getting a bunch of different projects. And so I'll just go ahead and put, like we saw before, I could just say get 22. That'll return just this object. But I also could say the tickets for this individual project. And so here I'm not including the project itself, right? I'm returning the list of tickets that belong to this object. Just like if I'm going to make another version of this, if I was just looking at tickets, what I'm being returned here is exactly the same kind of information as I got when I was returning this, right? It has an ID, has an employee assigned to it, has a project assigned to it. Doesn't have to include the project in every case, especially since you're searching for those projects, though this is not uncommon. And the idea here is that you should be able to navigate down to collections that belong to individual items, that this relationship or this association is defined in the URI. In fact, we should be able to take this even further and say, let's go get the ticket number 6. That is a ticket that belongs to projects 22. And then it's just going to return us our simple object. Whereas, of course, you could still get it from the straight ticket API. But the real question is, will you ever need tickets that don't belong to a project? Do you need to add this endpoint as well? You may or may not, but it might be useful if you're using something like a query string to query the tickets. This way we don't have to end up doing something like project ID equals 22, right? That's not a valid search to me. This is not preferable to this. This reads a lot better, and the ID here, because it's a query string, is optional. Whereas here we're saying you want to get the tickets to this specific project. All these parts of the URI here are required. Make sense? So let's talk about paging next. In almost all cases, lists should support paging unless you know it's a small finite set. What you want to avoid is the ability to get every object in a database. You might not think about paging when you're designing your API initially, but imagine later as this project is 5 years old, 10 years old, getting a list of anything that is too large is going to overload your server. Using query strings for paging is a pretty common approach. You can see here where in our tickets, we could specify what page, one being the first page, and how big I want each page. Now, the page size really depends on your API, and it's something you want to think about when you're doing the design. Maybe you always want to have a fixed page size. It's often used here so that people that are using the API can decide how much information is useful to the user. You could also see that when people are designing, let's say, a website using your API, you might want page size to be configurable simply because the UI might want a special number that makes it look pleasing on each screen. So 25, as long as they're in rows of 5, is going to look clean and not have dangling members there. But you might want something like 24, something that is an enumerator of 12, because that works well on different size screens. When returning data for paging, it's pretty common to use a wrapper to imply that paging. So returning the number of total results that they could have gotten and then show the next page and the previous page is just URLs that they can call without having to really think about it, and having a member that is the actual results of the call. Let's see that in action. So let's look at some paging options. Back in our example here, we were using tickets earlier, and one of the things that might not be obvious is when I request for tickets, I'm getting this wrapper object like we had talked about in the slides. Whereas there are 100 tickets in our system, previous page is empty because we're on the first page. There is no previous page, and it's defining a default page size. You can see the next page is defining both of these as page and page size, but we could certainly change this by saying page size equals 25 and executing this again. Now the number of results we have here are going to be 25, and we're going to get that same information. So if we take this and get page 2, you can see now we're getting page 1 and 3 as URLs to go get this particular query, but still including these pieces of information. The one thing about paging is in some cases, you do have the ability to use headers for the paging instead. So instead of having this wrapper, you might have all the same information in as headers. It really depends how you want to use these headers, depending really on the users of the API. Some might be more comfortable with just having the results as the body of the response, and then they could more casually look at the headers to get all this information. One of the reasons sometimes that is chosen is if we come up here and look at tickets for, let's say, 22 here, you'll see it isn't paged, right? It's just getting all the customers because we know that there's going to be a finite size here in tickets. We don't need to enable paging. That's one of the reasons why you might want to have two APIs here. But in some cases, you might not want both of these APIs to return different shapes, right? This one will return a shape that includes additional information about paging, and the other one just returns effectively what is in this results list. That may or may not be preferable. In fact, if we come up here, and I'm going to get rid of the page sizes in the header here, and I'm going to say use headers equals true, this could be an option that we turn on or off, so that for the people who really do want the just simple result, we could then have these headers, expagination in these cases, return the same sort of information. Let's take a look at error handling next. Invariably, writing an API means you might have issues. We are going to need to know how we're going to handle errors. Now, while error handling could just be status codes, 300, 400, 500, for errors, we often want to design what the results of an error actually look like. So how do you communicate these errors? And how do you help the user recover from those errors? That's the core of what you need to figure out when you're designing error handling. So here's an example. Often when we have an error, we want to return an object with error info in it. So we have some bad request, and that request might include a JSON object, if you're returning JSON normally, with information about what is wrong with the request. They've tried to post something up to the server, it doesn't have a supply ID, so you're going to list this. In fact, there's a standard format for this that you see in a lot of frameworks. Remember, bad request isn't something that they've done that's egregious, it's often just validation failures. For obvious errors, this isn't necessary. So 404 not found, you usually don't need to return an error object with it unless the not found is something specific. We didn't find this because the record had already been deleted. Might be useful to go through your API, but certainly not necessary. Let's see this in action as well. So let's see how errors could be handled. Let's create a new post. I'm going to borrow this for a minute. Let's say I want to go to customers, right? So we're going to need an accept header for application.json, and we're also going to want to tell it that we want the content type to be application.json. Let's go ahead and just create an empty object here. Well, see, it just gives us a bad request because it cannot figure out at all what we're trying to bind to. So let's go ahead and say company name, and let's say contact. Has figured out what it wants, even though this is a very incomplete object, and it's actually telling you one or more validation errors occurred, right? It's saying company name must not be empty and that the length of the company name must be at least 5 letters. This information we're giving back to say why the bad request was a bad request. And so what if we just say Box is the name of our company? It's going to return us more interesting information. It's not going to say it's required anymore, but it is going to say the length of company name must be at least 5 characters. We only use 3. And so these are the kinds of information that you can send back to the user to help them figure out. You might imagine someone building a website based on your API will be able to look at this and go, let's show them these errors in the UI. Or it might be something else for developers to say, hey, what you're trying to do isn't working. This is the exception type I got, or this is some error message I got. So it can be up to you how you return that data. But in many, many cases, when you have an error, you should be returning some information to help the developers figure out what is wrong. Make sense? Let's look at caching next. So let's talk about caching. One of the tenets of REST itself is that things you get from the server should be cacheable in some way. Supporting server-side caching is good, but we're really talking about client-side caching. We're talking about using HTTP to know whether an object is new, whether it needs to return a new object, and we can do this with headers. So this is how it works. User makes a request, we get some information back, and in the response, we return not modified. That means that this request hasn't been modified since the last time they asked for it. So instead of returning it and telling them that there's new data, this result of not modified is really saying the version you have is fine. Because what you can see here is in that header, we're going to include information for what version of the object that we actually got last time. Now, of course, on the first request, no version information is going to be in here. That response is going to include what version it is. When you're doing puts, you can use if match. So you have that version number still, but if match is saying, go ahead and update this if it hasn't been updated in the meantime. That last XYZ is some magic string that's going to tell the server what the version is that you retrieved. You made some modification to that object, and when you try to put it, you're just telling the server, please make these changes if I'm dealing with the latest version. And so in that response, if the if match fails, you get a 412 precondition failed, because that if match is a precondition of the execution of that put method. The way most people handle this is with something called entity tags or E tags. The support for strong and weak caching, effectively telling them whether this is a concrete version for the object or whether it is a temporary version for the object. These are returned in the response as headers. So the E tag for this object would be this magic number. And for weak caching support, you'll see that the E tag is prefixed with this W/ and then the number that you can use. And the weak just says that this number isn't tied to that individual object. Normally, weak caching is something that may be returned from a server caching element. And this way you can do a request if none match. So here we're making a request and we're saying this is the version. If there is that version, please give me that version. And that's why the 304 would return this, would say, hey, this hasn't been modified. The version you have is the latest. This would allow you to do things like poll for changes and those sorts of things. And for put and delete, this would say that we would do this put if the version matches, just like we saw in the slides, and that 412 will indicate that it did fail. Let's take a look at this in action too. Now let's take a look at how caching would work with e-tags. I'm just going to start with a simple get. I'm going to go ahead and get a specific customer. And let's go ahead and put the accept header. And so we can get this object, and you'll notice one of the headers that's being thrown in here is the E tag. You can also see this expires tag and last modified time. These are both used for browsers to know how long to cache it in browser cache. But we're talking about API cache. So what happens if we then say if none match for our E tag, right? So if I want to get this, unless it hasn't changed. And so let's go ahead and execute it. And we can see it's not been modified, right? And so we can assume the one we had before is going to continue to work. But what if we then do the same thing for put, right? Let's go ahead and get this object again. And here I'm just going to borrow these. I'm going to give it a content type. And if I send this request, you can see what my E tag is right here, right? And so I'm going to say if match, there's my E type, right? It has to be the same object. Let's make an innocent change because otherwise the object hasn't actually changed. So I'll just change this to 9,000 and I send this request. We got the update for 9,000, but we also got a different E tag. So what if I try to execute this again now that it has not changed? We're going to get precondition failed because this version was the version we retrieved, right? What we would have needed to do is take that E tag from the put and know that is the latest version we have. And so this might be a little confusing in that these E tags are just magic version numbers that you can use on the client side. And so when you're designing your API, it's a good idea to think about using versioning for this very purpose. What's important to think about is when you're building an API, you may not think about how long someone may hold on to these objects. Now, if you're on a web page and you have a SPA or some other mechanism for reading your API, that's fine. But imagine in some sort of app, like a phone app or a desktop app, where you may get the data and then it take weeks before you decide to refresh that data. What if the change is made, you allow them to come in and post without having a version check on it? It might write over 5 days worth of changes that someone else did. This all depends on the nature of your API, whether this is an important feature for you to emphasize in your API. Let's take a look at what I call functional APIs next. Let's talk about this concept of functional APIs. When we think about writing APIs, I've been pushing you towards this idea of REST or RESTful, but we also need to be pragmatic. There are cases where you want to be able to expose an endpoint or an API that does something functional. You're not dealing with resources necessarily. You're actually doing something. And so you want to make sure these are well documented and well secured. and they should be completely functional. So they should be doing something very specific. This is not an excuse to build RPC APIs all over the place. This is really about the exceptions. If functional APIs represent more than maybe 1% of your full API, you're probably doing it wrong. Let's see some examples. So you might want a function that returns this known data. You might not have tax as an object that you return, but instead some API that calculates the tax based on state and what the total is before tax. You might have one that does something dramatic like restarting a server. Probably not good in production, but you can imagine having this if you really, really needed it. So functional APIs are about executing some operation. They're not about changing data. If you're changing data because of a functional API, you're probably doing it wrong. Let's take a look at a functional API so you can see what I mean. Let's look at a functional API. So in the server we're using as the demo, I have an API called data dump changes. And the reason I put this in is obviously if people are using this for a long time, they're going to be making changes. At some point, we might want to just reset all the changes so that the database doesn't become too big or whatever the case is. And because this is a special functional API, I'm not going to use get, put, post, or delete. I'm actually going to use options. This is a verb that you can use to do certain out-of-the-box things. And so I like to use options in this case. It's also less discoverable, I think, until people watch my courses, of course. And so when I execute this, you're going to see it return to 200 like you would expect. And that actually changed the database to not have any of those objects in it. So let's see and test that it actually worked, right? So here I have that original customer that we created, and it has an ID of 26. It's saved it to the database. If we come down here to get 26, we're certainly getting that, right? It's executing it, returning it. But if we dump those changes, right, then this shouldn't work, right? Not found. So that functional API performed some task that, in this case, my example site was useful to do, which is bring the site back to a known state. By dumping all the changes, we still get all our original data that we wanted. It just got rid of any changes that were done after that. Make sense? Let's talk about async APIs next. So asynchronous APIs might not be what you're thinking. Certainly in the specific language you're going to build your API in, you may be using asynchronous programming. But I'm really talking about APIs that really aren't RESTful in nature, but need to have, let's say, long life polling or a push or pull mechanism. And this is where APIs can get really interesting. Using solutions that aren't REST instead of trying to pinhole in them is probably the way I would go in most cases. So some async API solutions to consider are Comet, which is for long-lived polling, gRPC, which is for well-known APIs on both ends, and that supports bidirectional and unidirectional communications, SignalR, which allows you to do things like multicasting, Firebase, Socket.io, etc. There's a lot of solutions out there that are going to be important when you think you need something that is different than resource-based management of state. A classic case here would be the little ticker you have on a website that shows, let's say, the current stock price. You may want to, instead of having the website call the API 1,000 times until a change happens, have something like a SignalR solution that has the server call them once a change has been made. So the important point here, as far as I'm concerned, is that you're going to think about APIs as being beyond just RESTful APIs. There are other kinds of technologies out there. Often in organizations, you're going to be using REST APIs for maybe a majority of your resource-based APIs, but you still might have a handful of these others for specific use cases. Let's wrap up this module. So in this module, I've shown you how designing associations can make your APIs more readable, more intuitive, easier for developers to work with. I've introduced you to caching as a way you can handle REST, but you must plan for that caching ahead of time. It should be part of your design of the API. And I've introduced you to functional APIs as a way to perform certain individual operations, but to be sure that they are the exception, not the rule, for when you design your API. Up next, we're going to talk about versioning APIs.